Hello everyone, this is Niteen Mohod and here we are going to discuss LED, that is light emitting diode. LED emits light when connected in forward bias mode. As you know, there are two modes of connecting the diode, forward bias and reverse bias. So far LEDs are concerned, they are always connected in forward bias mode. Here, when the LED is connected in forward bias mode, electrons in higher conduction band on N side recombines with the holes in valence band on P side, and the energy difference on the recombination of these charge carriers is given out in terms of light as well as heat. While in semiconductor diode, which is made up of silicon or germanium, energy is given out in terms of heat, while in LEDs, along with the heat, light of different colors is given out, and it is possible because of the material used in it. For example, gallium arsenide, which is used for IR radiations, which are invisible, gallium phosphide for red or green light, and GaAsP, that is gallium arsenide phosphide, which is used for red or yellow, that is amber light. You can see the diagram where the construction of the LED is explained. Here the N-type layer, this layer is a N-type layer, is grown on a substrate which is at the base, and P-type layer is deposited on N-type layer by diffusion method. As recombination is expected to happen in P-type, but P-type region, it is kept uppermost. Metal anode connection with gap in between this P layer, topmost layer, and the metal anode connection. This provided at the outer edge of the P layer actually, so that the light should emit through the gap. So you can see here the light waves which are coming out from the gap which is in between anode and the upper edge of the P-type layer. To reduce the problem of reabsorption, LEDs are made with dome glasses, dome lenses actually, that we will see in the next slide that how dome lenses are there. A metal gold film is applied at the bottom of the substrate to reflect the maximum possible light and also to provide the cathode connection. So here the anode connection is provided from the topmost layer and the cathode connection will be provided from the bottom layer. LEDs are encased to protect. As LEDs are made up of semiconductor material, they are having life of more than 10,000 hours. They are operated at 1.5 volts to 3.3 volts, and the symbol of LED is very similar to the semiconductor diode, only the difference lies in the arrows are shown which depicts that the emission of light. Here you can see the actual LED how it looks, and this is the dome type lens where from because of which the reabsorption problem of light is avoided. Second thing is the shorter leg of LED is always treated as a negative and the longer one is positive. So far the characteristics are concerned, they are very similar to the PN junction diode in forward bias. So they are almost linear as the forward voltage crosses the cut-in voltage. Cut-in voltage means where from actually the diode starts conducting. So far the applications of LEDs are concerned, they are used in visual displays, in optical devices like optocouplers, on-off indicators in various electronic circuits. LEDs emitting infrared light are used in remotes and burglar alarms. 7-segment displays is also one of the application of LED. While disadvantages of LEDs are characteristics are affected by temperature, needs comparatively large power for operation, reverse breakdown voltage is low which is around 3 to 10 volts, and they draw considerable current from the battery, and they draw considerable current from the battery. I hope the idea about LED as an optoelectronic device, its construction, characteristics, and applications and disadvantages are clear to you. Thank you.